Hello everyone, this is your friendly neighborhood engineer Yusuf. Um, so after a little bit of a hiatus, I've come back again, and I want to do trying to do a few more videos for basic engineering problems. So I picked a very simple one today, calculating centroid of an area, right? So basically, what centroid means is just the center of a 2D diagram. Okay. For example, if you have a rectangle, if you have this rectangle, and if you say where the center is, then you would say somewhere, somewhere here, right? Um, but if you have a complex figure, something like this, something like what I show here, then we need a little bit of calculation to find that out. Okay, so that's what we're going to do. I have created this table here, and I'm going to explain what this table means, and then we'll go ahead with the calculations. Um, for now, don't worry about these two columns. These are used for to calculate the moment of inertia with respect to any axis. But for now, we'll just be dealing with this part of the table. Okay. So basically what I've done is I've divided this shape into three rectangles. Okay, I'm calling this the top rectangle, the middle, and the bottom one. Okay, so the procedure is very simple. For each one, we're going to calculate its area, and also we're going to see where the center of that area is with respect to this axis. Now, here's the thing. We all so for the centroid is a coordinate, right? X comma y. It's a coordinate. With respect to what though, right? So let's establish our axes. Okay, I have one already lab. This is our x-axis. Let me call this xx, and then I'm going to have another one right here. So this would be my this is my y-axis. Okay, all right. So the centroid, like I said before, centroid is the center of this area. So imagine a little cardboard which is cut in this fashion, and then you want to hang it to your ceiling with a thread in such a way that this cardboard should be horizontal with respect to the ground. So where will you support it? Where will you tie the string? That's what we're trying to figure out. Now, one thing you can say intuitively is along this x-axis, right? Let me say x here, and x, and this is y and y. So along the x-axis, we know that it is a symmetric figure. So the centroid will be along the center line here. So if I draw, so it'll be somewhere on this along this line. Okay. So we know the x dimension. So for centroid we need x comma y. Okay, so we already know the x because it'll be somewhere. This is the center and it's a symmetric figure, so we can say it's somewhere on this. Now the dimension of this, the distance of this from our y-axis is, so the x dimension is half of this, we can say half of the length of the bottom rectangle, so that is 100, comma. Now the y is what we got to find out. So this entire table is what I'm using to calculate the y dimension, right? The y distance, and they're all measured from this axis, from this x-axis here. Okay. Let me get rid of this for now. All right. So for each figure, we'll find the area and the corresponding center with respect to, we'll find the y dimension with respect to the x-axis, the height actually, right? So the area of the top rectangle, area of the top rectangle is what? 100 times 20, right? 100 times 20, okay? And the y distance, so where is the center for this of this top rectangle? It's here, okay? And what is the height of that from this x? Okay, what's the height? So we know this is 20, right? This is 20 plus 100, 120 plus half of this one, half of the height of this rectangle. So again, 20 plus 100 plus 10. Okay, so I'm going to write this down. 20 plus 100 plus, sorry, plus 10. Okay, 130. All right. And then we're going to do that the same thing for the middle rectangle. Right. So the area is the width is 20 millimeters and the height is 100. So 20 times 100 is 2000. And where is its center? The center of this rectangle is here, right? And how far away is that? What is the height of it, right? Along y-axis. What is the y dimension of that center? Okay. So that would be 20 plus half of this 100, right? So 20 plus 50 is 70. So I'm just going to put 70 here. Right. Now, same thing for the bottom one. The area is 20 times 200, right? That's 4,000. Okay. And its center, say, is here, right? So how far away is that from the x-axis? What's the y dimension? It is half of 20, obviously. So that's 10. Okay, so that's it. Most of our work is done here. Okay, the only thing we need to do is multiply the area times this y. So I'll say area times y, right? And then we need to calculate some totals. Okay, so I'm going to do that here. Where is my auto sum? Okay, and then we need, right. So everything is done. Basically, all we need is, we know that the formula for centroid is sigma ay. That means sum of all ays divided by sigma a, sum of all the areas, right? So I'll say sum of all a times y, a times y divided by sum of all a's. Okay? Maybe I should do, all right. So here I'll say equals to this divided by uh, sum. So I get 55 millimeters. So all of these dimensions are in millimeters. So this is 55 millimeters. So the y dimension, so y is equal to, so the y dimension is 55 millimeters from here, right? From this x-axis. So that would be, so so 20 plus maybe 30, right? Uh, somewhere, maybe somewhere there. Okay. So we're going to change the color of that just so it looks different. Okay, so that is the centroid. That means this is where you would hang it, um, hang this picture from the ceiling, so it is balanced. And also think intuitively, right? If the top rectangle and bottom rectangle were the same size, then this centroid would line up here, right smack in the middle of this picture, right? But since the bottom triangle is bigger, the bigger it is, then it keeps drawing more towards the bigger rectangle, right? So that's the common sense check. Okay, so centroid is x comma y. So x dimension, like I said, is 100. Okay, this just by intuition we could do the same table for x, right? um, and then the y dimension is 55. Okay, right. A couple of things to remember. This dimension, this x comma y, is with reference to this x and y axis, right? This is, so if you consider, if you put your x and y axis somewhere else, then this dimension, then this coordinate will change, obviously. Okay, first thing. Second is, we could have divided this picture in several different ways, but this is the easiest way to divide it, like top rectangle, middle vertical rectangle, and then the bottom rectangle, but there are many ways to do it. uh, Other thing is, this, all of this finds the y part of the centroid. To find the x part of the centroid, we have to repeat the same thing, just that the areas, everything will be the same, just that in terms, instead of y, we would have x here, and then we would show the x dimension, the x dimension of this, of each of this yellow centroids from this axis, right? So, and then you would get the same answer, you would get 100. So maybe that's a good exercise. Try it out and see, try to recreate this Excel sheet. And in the next video we're trying to we'll do the moment of inertia part. Okay, that's it for now. Please subscribe to my channel, not because I want to make money. Well, if I make money in the process, good, but mostly because it's a challenge from my 8-year-old, that I don't have any subscribers, so I've been getting a lot of taunts from her. So please subscribe to my channel, and I promise to put more videos soon. Bye bye.